Hey, sixth graders. Today we will be doing lesson 5.5, using tables to represent equivalent ratios. That's a lot of big words. Using tables to represent equivalent ratios. And you will have two learning goals in this lesson. The first one says that I will create tables of equivalent ratios. And the second says I will use known values in a table to determine equivalent ratios. So there you go. Learning goal number 1, I will create tables of equivalent ratios. And number 2, I will use known values in a table to determine equivalent ratios. Make sure that you pause the video so that you have a time to write these two learning goals in your notes. And I kind of skipped ahead a little bit, just jumping right into the learning goals, because I forgot to remind you to make sure you have your binder and to make sure that you have pages 342 and 343 from your textbook, because you're going to need them in order to get your work done this evening. So we're going to start with a table on page 342. So when we're looking at this table on page 342, we are comparing how much something weighs on Earth compared to how much something weighs on the moon. The stronger the force of gravity, which means the harder that item is being pulled to the ground, the more it's going to weigh. So we can tell on this chart that the gravity on Earth must be stronger than the gravity on the moon, because something that weighs 60 pounds here on Earth only weighs about 10 pounds on the moon. That means that the gravity on the moon is nowhere near as strong as the gravity is on planet Earth. So the ratio of weight on Earth compared to weight on the moon is about 60 pounds to every 10 pounds. So we can use ratio tables just as another model to show relationships between two quantities. So basically, tables are just another organizational tool that we can use to solve our problems. The second ratio on our chart shows us that something that weighs 30 pounds on Earth only weighs 5 pounds on the moon. So both parts of the 60, so you have 60 divided by 2 and you get 30, 10 pounds divided by 2 and you get 5. Both parts of the ratio were divided by the same factor. Both parts were divided by 2. So then, when we add 60 plus 30, we get 90 pounds of weight on Earth. When we add 10 plus 5, we get 15 pounds of weight on the moon. Now on my video, I'm just going to leave the screen here at page 342, but you all are going to need to look just right next door on page 343 for the couple of questions that we need to answer. Question number 1 asks us how we would describe this second ratio of 30 pounds on Earth to 5 pounds on the moon. How was that solved? How did we come up with the answer to that? I want you to take a minute to think about this and then write your answer on your sheet of on your answer sheet. Both parts of the 60 pounds and the 10 pounds, they were both divided by 2. So 60 divided by 2 equals 30, 10 divided by 2 equals 5. Question number 2 wants us to think of another strategy to find the ratio of 90 pounds on Earth to 15 pounds on the moon. Pause the video so that you can think of your own strategy. And, 6th grade, there is more than one correct answer to this problem, so it's possible the strategy you come up with might be different from the strategy that I have. Does that mean your strategy's wrong? Nope, it sure doesn't. So I think it would work if we multiplied the ratio of 30 pounds to 5 pounds if we multiplied those by 3. So 30 times 3 would equal 90. 5 times 3 would equal 15. What do you think? Does my strategy work? Did you come up with that same strategy of multiplying by 3, or did you come up with something different? I look forward to seeing what you came up with in class. We will be doing a lot more using tables to find ratios while we're at school. I'll see you there.